Hey everybody, this is math video number 14 and it is going to be the last math video of the school year. I know you're super excited about that, as am I. You can tell by the fact that we're sitting here with some math tiles in front of us that is going to be another math tile lesson, sort of our last math tile lesson. But I am going to greet you by saying hello. Hello. Hi, this is your last time you're going to see me on video unless you want to re-watch one of the previous videos, which is you're welcome to do because they're, on the internet. All right, let's go back down here to our math tiles that we're looking at here. So I know you remember the names of these tiles, but this is a nice set here. I'm going to mark them up. This is a y squared tile. This is an xy tile. This is an xy tile. This is an x squared tile. This is a y tile. This is an x tile. This is a 1, and a 1. All right. So what I want you to do, I know this is kind of a fancy design. Ooh, so fancy. But I'm going to have you guys take a moment and draw this tile set in your journals because this is what we are going to be working with. Just this one picture, this one design is what we're working with today. So please go ahead and take a moment to draw it. Now, it doesn't have to be to scale exactly, but you do want to make sure that you remember that your XY tile has a length of Y and a width of X here. And so everybody's got a little neighbor that's the same length, right? We've got the Y squared tile here has a length of Y. The XY tile has a length of Y here. The width of X, which is our X squared tile here. There's another X tile up here for you to remember. So, and then you got your 1 unit tiles over here. So what we're trying to do in this particular problem is discover the area and the perimeter in simplified form for this design. All right. Then we're going to do one more thing with it, but we'll discover what that is a little bit later. All right. So the first thing I always want to do when we're dealing with a problem like this is to label everything. So if you need to pause this video to draw this figure, then go ahead and do so, and then you can unpause it when you are ready to move on with the labeling. But I'm going to move forward here, and hopefully you just paused it and drew this, or you are a really quick artist and you didn't need to pause it. I'm not sure. But anyway, this is what I'm looking for when I see your notes attached to this video assignment. Is the notes that we're working on today. So this length here is Y. This length right here is X. Right? This is a length of X. Right here is a length of X. Actually, can I trace it? Can I trace it without bumping it around? This length right here is X. This length right here is X. This length right here is X. This length right here is Y. This length right here is 1. This length right here is X. This length right here is 1. This length right here is X. This length right here is 1. This length right here is Y. Then we've got 1, 2, and 3. So we have a length of 3 right here. We can label it as 3. We know that this is length 1, this is length 1, this is length 1, right? Ooh, I forgot this one. This length right here is 1. Did I skip anything? Then this length right here is 1. We got this Y. The only trick is what is this length right here called? We know that this length from here to here is Y. But it is covered up by these 2. So Y minus 2 is going to be this length right here. I know that this is 3 because here's 1, 2, 3, but from here, y down to here is y, right? So this right here is 1, which is covered right here, right? But from here to here is y, and these are the only two that are covering up right here. So y minus 2. All right, I think I've traced the whole thing. Can I do that and just do this? Oh, no. All right, so here's my x squared tile. Then I have my xy tile. Here's my x tile. Here's an xy tile. Here is a one, and a 1. Here's a y tile. Here's a y. Nope, a y squared, Mr. Dell. Look at that. All right, there's my drawing. That's where it is. All right, so let's start with our area, right? I think area is so much more friendly. The area, if you recall, is just what tiles do I have? Because this is the surface of this is valued as xy. That's why we call it the xy tile. The surface of this one is y squared. That's why we call it the y squared tile. This is surface of this is x squared. That's why we call it the x squared tile, right? So adding up the surfaces of all of these tiles is all we have to do. So I will tell you that your teachers in the future will like you to organize things with the exponents first, the double variables second, the single variables third, and then a number, right? So my area is going to be y squared plus x squared plus, how many xy's do we have? We have 2 xy's, so I'm going to say 2xy. And I put my parentheses there just to show that it's not 2x times y. It's 2 of the xy's, right? Plus x plus y plus 3. All right? So that's my area. I named my tiles. I got that tile, check. I got this tile, check. I've got 2 of these, check, check. I've got x, check. I've got y, check. I've got 1, 2, 3. Check, check, check. That's all of my tiles. So that is my area. My area is naming the tiles, and I just named all of them here. It's an addition problem, adding this surface plus this surface plus this surface plus this surface plus all of these surfaces, right? Perimeter. Is a little bit longer. And when I say a little bit, it seems like it's considerably longer. Because I'm going all the way around this shape, right? There's going to be a lot of simplifying I have to do here. So why don't we pause it? Make sure you got your area copied down. You will need to have this copied down for our next step that we're doing after we do perimeter. All right. So take a moment, pause the video so you can copy down our area and make sure you've got it. All right. All right. So I think what I'm going to do, I think it's smarter if I actually start with my perimeter over here. All the way over, because I think I'm going to need this whole space for this really long equation that expression I'm about to have. So I changed my mind about how much room I wanted to have. All right. And again, so I don't accidentally not count something or double count something, I'm going to put a little dot here as a reminder, and I'm going to start here and go clockwise around this shape, counting up all of the edges, the measures of the lengths of the sides. So I have that perimeter. All right. So it is a x plus 1 plus x plus 1 plus y plus 1 plus 3 plus 1 plus y minus 2 is that distance, plus y plus x plus x plus x plus x plus y plus 1. And that took me all the way around the edge. And my computer turned off there, so I'm going to read it again real quick. It's x plus 1 plus x plus 1 plus y plus 1 plus 3 plus 1 plus y minus 2 plus y plus x plus x plus x plus x plus y plus 1. All right, so now I want to simplify this expression. My area is already simplified. It's pretty simplified because the only thing that was repeating was 2xy's and these 3 that we added up already, right? But there's a lot here that needs to be combined if we're going to simplify this expression. There's a lot of x's, there's a lot of y's, so let's figure out what we got. And it's okay for you to mark up your expression. As long as you have this written out here, it's okay for you to mark it up to keep track of it all. So how many x's? Let's combine all of my x's first. I have 1, 2, 3, 4, 5, 6. 6x plus how many y's? 1, don't count that one. 2, 3, 6x plus 3y plus y minus 2, because that is a unit of measure. That is what we've measured here. That's this length right here. So it's its own little measurement. And that's all my variables, right? Now I just have to figure out plus what? 1, 2, 3. Plus 3 is 6. Plus 1 is 7. Plus 1 is 8. So our simplified expression, when we simplify this whole thing, is 6x plus 3y plus y minus 2 plus 8. All right. So I'm going to go on to my next piece of paper here to make sure that I have all of that down. I have my area equals y squared plus x squared plus 2xy. And remember, this is x times y. That's why these x and y are snuggled together. It's x times y plus x plus y plus 3. Right. Oh, and I was like, why do I have a 2 here? Why don't I combine those? This 2 is times this xy. So this is one expression right here. So I can't combine this 3 and this 2. The 2 has a different job here. It's 2 times xy. All right. So here is your next step. We've got this expression. We know what we know about order of operations. That's please excuse my dear Aunt Sally. I want you to solve what if we did know what x and y were valued. If x equals 3 and y equals 5. If x equaled 3 and y equals 5, what would the area be? Now, I'm just making that up because we know that x is not 3. We know that this is 3 right here, right? But we're not going to worry about that. We're just going to pretend, what if x was 3? Because x is a variable and x could be anything. If x were 3 and y were 5, what would this value be? So what you need to do now is rewrite this expression with these numbers included. So that would be 5 squared, because y is 5, plus x is 3, 3 squared, plus 2 times 3 times 5, plus 3, plus 5, plus 3. So every x, we substitute a 3. Every y, we substitute a 5. And including the exponents gets, attached to it. All right, so now we need to solve this. Order of operations. Please excuse my dear Aunt Sally. Are there any parentheses in here? Yes, there are, right here. So we do that first. Now, what I want you to do is I want you to solve this problem one step at a time. Don't skip any steps. Don't cut any corners. Everything else gets left all by itself until it's ready to go through, until we get to it. Are there parentheses? Yes, there are. So 5 squared stays the same. 3 squared stays the same, plus 2 times 3 times 5, that's 15. Plus 3 plus 5 plus 3. So everything else stayed the same. The only thing I changed was the parentheses, because that's what's first. Now, are there any exponents? Yes, there are, right here and right here. Now, when there's 2 exponents, we just go from left to right, all right? So are there any exponents? Yes, right here, we solve those. We're going to do our exponents. It's like a little checklist. 5 squared, that's 25, plus 3 squared, that's 9, plus 2 times 15, plus 3 plus 5 plus 3. Everything stays the same except for the one thing I'm solving for, which in this case is exponents. Now, remember, multiplication and division are best friends, so you can do whichever one happens first from left to right. The only multiplication I have left in here is right here. So I'll go 25 plus 9 plus 2 times 15 is 30, plus 3 plus 5 plus 3. Now I have a whole bunch of adding. No subtracting. That's all I got to do is my adding. So 25 plus 9 is 34, plus 30, plus, I'll cut us a corner here and add these things together. 3 plus 5 is 8, plus 3 is 11. Right? But I'm making my thinking clear by circling those and saying that's this, right? Here's this. So I combine these. This is here, that's there. Now I can just add those together. 34 plus, or 34 plus 30 is 64, plus 11 is 75. That is our answer. If the area was this, and if x equaled 3 and 5 was y. Then you substitute that in and solve it. 75 is it. You know what's coming next. You know what your next task is. Your next task is to find the perimeter. The perimeter, which we already discovered, was 6x plus 3y plus y minus 2 plus 8. We don't have any exponents here. Please excuse my dear Aunt Sally. If x equals 3 and if y equals 5, what is this worth? Solve that up. That is what's your homework. I'm not going to show you. You're going to do it. And I want you to do it just like I did here, where you're substituting in, solving one piece at a time till we trickle down to our answer. All right? Here is your work. This is what you got to do. This is one of your last homework assignments you will have for this school year. In your notes, I want to see all of this, all of it. I want to see the whole kit and caboodle. I want to see this drawing. I want to see this area and perimeter that we figured out. And I want to see you solving for area here And I want to see you solving perimeter here. All right, you guys are great. That is all we have. That is your assignment. Good luck. Thank you much. Have a great day.